photographers, so they're very specialised as well. And here we go, ESR, forensic scientist and technician. There might be a special search team, which is also with the police, and we also other experts such as a pathologist. Does anyone know what a pathologist is? No, so
okay, try and take a guess, like, try and take an educated guess. You?
Is it someone who tries to track someone down and tries to find carbon footprints?
No, not quite. Shall we take one more? Yeah. They are kind of finding clues. So a pathologist is someone who is a doctor, so they're medically trained, but they are specialised in figuring out why someone has died. So after someone has passed away, they will carry out a post-mortem and figure out, they're very specialised in figuring out why someone has died. And also sometimes we have the fire service come along as well. So forensic science is sort of based on this principle, so Locard's principle, which is every contact leaves a trace. So basically, everywhere you go, you're leaving a bit of you behind. So when you all leave this room today, there will be a little bit of you all left behind, whether it be fibres from your clothes, hairs might have fallen out, like just naturally out of your head or be on your clothes and shed off, and also your DNA. So your DNA is in all the cells of your body, and one way it's spread is in your saliva, so that's like your spit. So as I'm talking now, there's actually little bits of spit will be coming out of my mouth, apologies, front row, and you can't see it, but it would be enough to identify, get some DNA from
and prove you were here today.
Yeah, and prove I was here. So pretty amazing. So we're looking at a contact between a victim. So a victim is someone who is, that the crime has happened to. The suspect is someone that we think may have done it. Yeah. And also just the scene, trying to prove who's been there and who may not have. So can anyone think of some traces that criminals may leave behind? I'm going to go over to this side.
Fingerprints.
Yes, that's a good one. Right in the back row.
Yeah. Or fingerprints on weapons, like guns, knives.
Yep, may leave weapons behind. Yep. Yep.
Carbon footprint.
Carbon footprint, or even just like shoe prints.
Yeah.
So there's shoe prints. Yep.
Yep.
Yep, saliva. Yep. And we'll go over to this side. I'm going to do you still have your hand up? No, we'll go right over there into the back. Yep.
Oh,
Sorry, I don't know your name.
DNA.
DNA, yeah. Okay, so let's carry on. So this is my criminal. So he's my robber. So unfortunately some of you may have experienced something being stolen of yours, which isn't very nice. And my job is to help identify that person, but using science. So we mentioned fingerprints, and that is definitely one way. So hopefully you haven't had your house burgled, but if you have, the police may have come around and done their powdering looking for fingerprints.
Oh yeah, and powder all around the house.
Yeah, around window frames and trying to find fingerprints. So fingerprints are unique to everyone. So all of you will be different to each other with your fingerprints. And there's 3 sort of different classifications. So you have loops here, arches, or whorls. And I have got a project that I'm going to leave with Melissa that the teachers can do. So you can have a go at, if I can get this out of the thing, at making your own fingerprint from each of your fingers with something. And then you can have a go at identifying, and you might need a magnifying glass, identifying what type you might have. And each finger will be different as well. So that's quite a fun little project to do. Okay, shoe prints. We mentioned shoe prints. So yes, you can leave your shoe prints behind. And we have different types of prints. So you could have a positive print. So that is when basically you have dust on your shoe, or you've got something on your shoe like mud, and then you track that through like the house or something, which I'm sure you've probably done at home. You may have been out in the garden and you've walked inside and put muddy shoe print through the kitchen or something, and your parents might, or your mum might have been a bit annoyed about that. So that's a positive print. A negative print is when you may walk over a dusty floor and you take some of that dust away on your shoe, so you sort of leave a negative print behind. And also 3D ones, so that's when you walk in the sand, you know how when you're walking along the beach and you can see like your shoe prints, or you leave a trail of your shoe prints, that's like a 3D print. So we have different ways that we collect these prints. So we have a dust mark lifter, and that uses like electrostatic energy to like lift the dust up onto a film, and we can take that film away with us to compare to any suspect shoes. We also have gel lifts, and that's very similar to what they use for fingerprints as well. Yeah.
What if the robber had someone else's shoes, so then the other person might be in trouble?
I know, that is tricky, and that's when they have to look at all the evidence in a case. But yep, that is possible. It does make it tricky. So we, I guess as scientists, we just say what we've found. So we can just say, yes, the shoe print matches that shoe, and that's really all we can say. And it's up to the police to figure out the rest from their interviews and everything. And then and also photographs. So all shoe prints will be photographed, and negative prints are collected the same way. And with 3D prints, we collect them doing casting. So this is very similar. It uses a thing called dental stone. It's very similar to if you've ever had a mould taken of your teeth by the dentist. I don't know if you would have or not. But it makes like a little, kind of like concrete or plaster impression. So that's sort of the same way that we cast the 3D shoe prints. And I have an example of one here that you can pass around. So this is a shoe print that's been taken with dental stone. So it's just a powder, and you mix it with water. It's all mixed up to a liquid, and then it's poured into, so just like this, and then it's poured into the shoe print, and then it's left for quite a few hours to harden up, and then we can lift it out, and hopefully it will catch all the detail of the shoe.
Like with that one there, it's got.
Yeah, this one's really good. And yeah, you can see that it's been made by that shoe, or a shoe of that type.
And the ones with labels at the bottom, like mine, has got.
Yeah, sometimes that might come up, as it says, some words, some letters. Yeah.
And then it just helps you figure out what type of shoe it is.
Yep, it does. I can pass that around if you want to have a look at that. Okay, so sometimes clothing can be left behind, and from clothing we can be looking at fibres, any body fluids that may be on clothing, which we can get DNA from. There could be glass on clothing, so if our criminal has broken a window, sometimes most of the glass will go forward, but some of the glass will actually go backwards onto the criminal's clothing. So we can and then sometimes it can also be like paint. If they've squished their way through something, the paint from the door frame something may transfer onto their clothes. So there's lots of different evidence types that we could be looking for. Okay, so DNA. So who knows about DNA? Yes, quite a few of you. So actually you probably know what it stands for. So deoxyribonucleic acid. So this is the basic building blocks of life, and it's what makes you, you. And so you have half inherited from your mātua and half from your tupuna, so your mum and your dad. And it's unique to each individual. And each cell in your body contains your DNA. And regardless of what body fluid, so whether it's your blood or your spit or your skin, you'll have the same DNA in all of those different cells. And this is really good to help identify offenders because of the fact it's so unique. So it's like fingerprints as well, being unique. Yep.
Another DNA sample will be nails or toenails.
Yep. Yep, it will contain, so basically any part of your body that has cells in it.
If you have the same mother or father as another person, would that mean you have the same sort of DNA or the
Siblings still have different DNA.
even identical twins?
Identical twins do have the same DNA, but different fingerprints.
Yeah.
Yeah. So that is confusing. If the criminals or suspects are identical twins, that makes it really confusing and not very fair for the twin that's the innocent person. So we are currently doing some research to see whether we can distinguish between identical twins. So hopefully they do figure out a way to do that.
But what if identical twins do have the same
They have different fingerprints. So fingerprints are created when you're growing in your mum's tummy, and it's kind of as you're bouncing around and your skin's developing, it creates different ridges in your skin. So even identical twins will be moving around differently inside. So that's how they're created. So it's quite cool. This is just a bit about DNA, so it's a little bit confusing. So here we have our cell, and inside our cell we have a nucleus, and inside the nucleus is a chromosome, and that is your DNA, and it looks like this. So it's that double helix structure. So we just look at just a part of your DNA strand, not the whole lot, because that would take ages. Okay, so I talked a little bit about spit, also known as saliva, and we can obtain this from, so if you've had a burglar, he may have decided to take a drink while he is committing his crime and stealing stuff, and so he may take a drink from a bottle or a can. So we can, as I said before, we can swab like the neck area of bottles or the lip area, mouthpiece of cans, and we can get DNA from that. Also bite marks in food. So believe it or not, some burglars or robbers are very silly and they might decide to do a bit of a snack while they're in someone's house. Yeah, kind of like Santa, but he's a good guy. He leaves stuff, he doesn't take stuff. He's a good guy. He leaves stuff, he doesn't take stuff.
No, it gives.
So there is an actual case of a burglar, and he actually took a bite out of a big thing of cheese. And so they were able to get DNA from that by swabbing that area because he left lots of his saliva behind on that. Not as common these days, but when I was little, we used to lick the stamp and put it on envelopes. So that was a really good way to also get DNA from saliva. Sometimes though, you still lick the envelope closed, so we can get your DNA from that envelope. And also on clothing. So as I said before, when you're talking, you're dropping microscopic little bits of saliva here on your clothes. So if an item of clothing is similar to us, like a top, and they want us to identify who may have worn that top, because it might have been just discarded somewhere, we will test this area for saliva and send that away for DNA. So I mentioned another thing here. And so we lose around 100 hairs a day, so that's quite a lot. And there's 3 different stages of growth, and most of the ones that are just falling out are in a telogen stage of growth. And so we can't normally get DNA from them, but we can from the ones that come out that are actively growing. If they accidentally get pulled out, like by a hair tie or something. Okay, so because we're looking for these types of things, we need to be wearing protective clothing, so I'm not dropping my DNA or my hair onto stuff that I'm looking at, because I don't want it to come up all the time. But also to prevent that, we do have our DNA, when we start our job, we have to give a sample of our DNA, and it's on a database. So if a foreign profile or DNA profile is obtained, it gets run against the database to make sure it's not us, so anyone who's actually worked on that item. So we need to protect our hair. So what do you think we have to put on to protect our hair? We need to ask someone different. Yep.
Maybe plastic bag.
What, sorry? Plastic bag. So we have what we call a hairnet. So it's kind of like a shower cap, but it's just netty stuff, so it doesn't need to protect us from
It's like
water.
a spider's web.
It is a little bit. So like that netty stuff. So that's our hairnet. Saliva, what would we have to protect us from?
Like something to cover your mouth.
Yes, like this. Face mask. Yep. So we have one of them on.
That's what we sometimes use in the salon.
Yes, exactly. So you're not spreading your germs to others. Yeah, if you've got a cough. Yep. You could put a mask on. And for our clothes, we have, so in the lab, we have a gown like this that we put on over our clothes. I'm going to get two volunteers to do that. And then at scenes, we wear what I'm wearing here. So that's actually me working at a scene there, sieving through some debris.
The gloves.
Lots of fun. What's that?
Or you can just use tweezers. You could use tweezers like
Tweezers, yes, to pick up things. Yep, so we're not using our own fingers. So this is our coverall that we wear at scenes. So this is purely because it's more comfortable for like bending down and everything rather than wearing the gown. Pop that over there. And then what else we say? Fingerprints. We've got gloves, of course. And for shoe prints, so we don't have to wear this in the lab, but at scenes, we have little shoe covers. So these slip over our shoes. So, I need two volunteers from, so I've got you and you. Okay, so maybe if one of you goes over there, maybe one of you there. I'm going to give one of you, stand up on the edge here, the outfit that we wear at a crime scene, and then what we wear in the lab. So this is every time you go in the lab, we are wearing this. We'll take a pair of gloves. This is the trickiest part, putting your gloves on. There's your gloves. And then your gloves as well. So, don't start yet, because this is going to be a race to see who can get theirs on the quickest. Start a challenge. Okay, so maybe this half can cheer for, and this half can cheer for, what was her name? Felix. Okay,
Alicia.
Let's go, Felix. Felix is still getting a shoe cover on.
Hi, he's filming.
You're right in the way from someone.
Oh, you can sit a bit nice to sit down. Everyone has to sit down on the this is not be my bedding or bed. This is my
So you might sometimes see the police dressed up like this on TV. So yep, that's what we're wearing, and in the lab we just wear the gowns. Alright, so searching for blood. So we're quite often looking for blood on items of clothes. Okay, so to do this we use a really bright light. It's a 1000-watt lamp, and it gets very hot, and we are currently in the process of switching to LED because it doesn't get so hot. And we also use a chemical test to help identify blood staining as well. So to be able to say that something is a blood stain, it needs to visually look like blood. So what colour does it need to be? Red, yep. And it just has a very distinctive looking appearance, which obviously when you're trained to look for it, you know what you're looking for. And also we need to have a positive chemical test. So the chemical test is looking for a protein in blood called hemoglobin. And it's that hemoglobin that causes the colour change in the chemical test. And I'm going to show you that a bit later, but I might do it near the end. And I just also want to emphasise that not every red brown stain is blood. And you'll see what I mean when I've actually bought, not a real exhibit, but this is what our exhibits come packaged like. So we'll do that a bit later. And I've got our little chemical test that we use, which is just a little test strip. And this is what we use at Scene. So in the lab we use actually a different reagent, which is 2 liquids. But at Scenes we just use these strips. It's a bit easier, a bit less messy. So we'll go into that a bit later. You may have seen luminol testing maybe on TV when they spray a chemical around, and if there's blood present it glows. Luminesces, may not have, not sure. So this is something that we do to look for very trace levels of blood, so you can't actually see it visually. And this is really good for following a shoe print trail in blood, or any evidence that someone's tried to clean it up. Even though you think you've cleaned it all up and you've used bleach and everything, this will still show it. So this is just an example of a bathtub. So it looks pretty clean and white. And when we sprayed our chemical around, it looked like that. So obviously someone had tried to clean that up. And then also just this fridge, so it looks pretty clean. And then when we sprayed the luminol around, we got this. And also with shoe prints, that's the same. So this is just on carpet when we sprayed it around. So you couldn't see it, especially on that orangey brown carpet. And then this is a test print made with a shoe that's been submitted of a potential suspect to compare. Another interesting thing we do is tool marks. So our criminal burglar guy before may have used something to obtain entry to somewhere, and they may use something like a crowbar. And sometimes a mark is left behind on the door frame or the window frame, and if we're able to obtain something that may have been used, we may be able to compare it to the mark that's been left behind. Another thing is called physical fit. So this is really like doing a puzzle. So sometimes if a vehicle is involved in something, the vehicle may have broken bits on it, but have some bits missing. And then at the scene, we may have collected some broken pieces. So back in the lab, it's kind of like doing the puzzle. We may be able to join these pieces back up to the pieces that were still on the car. And that is pretty good evidence to say that that vehicle was at that scene at some stage. So there we go, all the pieces joined up. So piece A, piece B, and we've got all our little pieces here that have all joined up and made a pretty cool little puzzle. What's wrong with this picture?
They don't have the hairnet on.
She doesn't have her hairnet on,
Good thinking. That was bad.
or her face mask.
Yes.
So pretty naughty. But there she is using a bright light, testing something. Testing something in a car.
Own DNA could be falling, couldn't it? Her own hair.
Okay, so this is sort of the end of the talk. I guess it's just why I chose to do forensic science. And I guess the big one for me is you are helping to contribute to a safer society. So you're making the community safer for everyone using my scientific knowledge to help solve crime. We have lots of variation of work, as you can imagine. All scenes are quite different, and all the items that we receive in the lab are very different. And we do get to travel. So since we cover the South Island, and I partake in an on-call roster 24/7, so I don't know, when I'm on call for the week, I don't know where I'm going to end up within the South Island, obviously. And you also do get to go to conferences and things like that, so that's where a lot of forensic science people will meet up and discuss ideas and new research and stuff. And the future, so we're really getting into all technology things, which is a little bit scary, but very cool at the same time. So we do things like laser scanning, so we have a machine that shoots out lasers, and we're able, like this room with our laser scanner, we're able to, at the end result is like a 3D walkthrough map. So kind of a bit like virtual reality, where you can actually, the final product, you can actually walk through like a house and actually see how things were as soon as we got there. Yeah, kind of like a tour. Like they do that with real estate and that, I think, now. Yeah, so it's very much like that. So we use our laser scanners to do that. Also starting to use drones. So this is a photo using our drones to also capture crime scenes. Also using 3D photography, so we can actually look at a weapon from all angles and the staining and stuff on it, and also doing a bit of virtual reality for like training of police officers. And this is also my other job. I'm a mum to Eva here in the front row and little Jack, who you may have seen around. So that keeps me pretty busy as well. And now it can be question time, unless we want to do a bit of this.
Yeah, questions and break it up a wee bit. And
Okay.
do that. That sounds great.
Yep. Put your hand up.
You can make the lasers invisible, so it's on a long have to try and get through without touching the lasers. And then,
Like on movies.
and then also scanner line.
Yep. Well, when we're doing our laser scanning, we all have to like leave the rooms, because otherwise we would be in the final thing, product thing, in the computer. So we'll set up the laser scanner and we leave the room. And also because it's a laser, so it's not very good for your eyes. Yeah. No, because it's on a tripod thing, so it's just doing it. It's turning around 360, doing itself. So the only bit it doesn't get is the bit directly below it. It's normally just around anyway. Yeah. So does that kind of make sense? Oh, so obviously we're trained on where to put it, so we wouldn't put it directly over something that was important. Yeah. Or what we do is, if we're scanning this room, we would do 4 corners of the room to capture everything, and then it's all stitched together.
So if you freeze footprints, could we give a possible chance of someone having the exact same shoe?
Yeah, there is. And that's where it's really, the police, it's their job to put together other bits as well, and I guess it's when they find out, where were shoe prints, we do have like a database of how many types of those shoes are around in New Zealand, for example, like how many would have been for sale, how many were sold, like all that data is collected and that has to all be looked at as well. So, yeah, good question. I've asked you a question already, so I'm going to go over to the back row. Yeah.
What does the ESR mean?
So ESR stands for the Institute of Environmental Science and Research Limited. So as I said, forensics is part of that, but we also have another big part called environmental health. So basically all the science that we do there is making the community safer. So whether it be to do with water or food or just public health in general, so people aren't getting sick all the time, and then obviously forensics as well. Yep.
If you find pellets of gunshots or any gunpowder, do you use it to track down the suspect?
Yep, we do. So we have firearm experts, and they're based up in Auckland, but they cover all of New Zealand. Yep, and they do all that stuff. So we're trained to identify it, yeah, and collect it. So yes. Yep.
If you don't put lasers around the special fence, the workers will be able to get into them.
Oh, we only do that stuff afterwards. Yeah, so it's not beforehand. But yeah, but maybe some houses have lasers, so robbers don't Google them. Yep.
Any more questions?
We can't age a shoe print. No. So we don't know how long ago it may have been left there. We can probably give a rough estimation from, like if it's been raining or the weather or something, we can probably roughly say it's quite recent. But yeah, we can't really age them. And yes, one more. Last one.
What's your top priority when you get to the crime scene?
That is a good question. So our top priority, obviously the police would have shut it all down and it would have been closed off to the public. So that's where you see all the tape put up everywhere and there's no access. So our top priority is probably actually just coming up with a plan of what we're going to do. So everyone can coordinate and work together because it is a big team effort working there. And after that, it's probably just doing a general look around so we know what we're dealing with and we know what needs to be done. Yeah, it's a really good question. Got one more?
One more question?
One more question. Okay, I think someone needs to ask one. You haven't asked one.
Can you tell what size shoe it is by the bottom of it?
Yes, not necessarily from an actual number or anything being there, but just from the length of it, so we measure the length. Yeah, roughly work out. So as you saw before, if we get any suspect shoes come in, we actually ink that shoe and we make a test print of it onto paper, and then we make, from that bit on paper, we make an overlay, like a transparent film, so we can actually overlay it straight onto any prints that we've collected. So from that we'll be able to figure out if they're a similar size or not. Yeah. Okay. Do you want me to do any more questions? It's enough. Okay, do you want me to show you my exhibit I brought in?
Yes.
Okay. So we asked the police to bring in items in paper. This is so it's breathable, because if there's any sort of body fluid with DNA on it, we don't want it to go mouldy because that ruins DNA. So that's why we asked them to put it in paper. So it's breathing. And we might have to go over to that table. I'm going to bring my gloves. I'm going to bring this. And maybe we can get it around this table somehow.
She needs to get in.
Get out.
Yeah, move back. She needs to get
I need to squash in. Can I squash in here somewhere? Okay, I'm just going to put this down. Okay, so first of all,
Touch it.
so if I was, yeah, we have to cut into it. So if I was working in the lab, I would have cleaned down my bench And I would have laid down some paper. So maybe afterwards it's not going to be taken down. So I would have my item here. It's been sealed shut and the seal gets signed. So this is so we know that no one's tampered with it. Because we don't want that. Tampered means someone has got into it. So we don't want anything to have happened to it. So let's have a look here to make sure I tuck it the right way in these bags. Maybe if we just go down here. Alright. I'm trying to see. What have we got? Said one pair of jeans. There we go, we've got a pair of jeans. So,
Are they mine?
pop this down.
I get it. Would they be mine? I get it.
Inside. So let's have a look here. So we would receive an item like this, and I would want to lay it out and look at it. So I would. They're pretty dirty, aren't they? Not very nice. So I would get out my bright light to look at these, although you probably don't need your bright light because you can just see stuff. Alright, so there's quite a few stains on here that potentially could be blood, do you think?
Yeah.
Why do you think that?
Because
Red in colour. Yep. So, shall we do some testing?
could be
So I will show you what you're looking for. So here, this is what, so any chemical test we're doing, we have to do a control. So this is to make sure our chemical reagents and tests are working. So I have this little card here. So that is actually blood. It's just pig's blood. We don't use human blood. So pig's blood is very similar to human blood, so that's why we use it. So we grab our little, so this is a little thing of water. So we've got a little ampoule of water.
Can't drink it.
And we put a little bit, you probably could drink it. I wouldn't, but you probably could. So we do a little drop on the end there. And then when we rub it onto the stain, it changes green, which means it's positive for blood. So you get that colour change happen. So if it doesn't go green, it's not blood. So would anyone like to test some stain?
I want you.
Might take it off you, so maybe 5 of you. Does Melissa want to pick? And you'll have to put gloves on. And I'll hand you a pair of gloves. Yellow t-shirt, here's some gloves for you. They might be a bit big, I apologise. Alright, here you go, some gloves for you, so you can come to the front. What about... Here you go, some gloves for you. So we've got 3, maybe 2 more. That one, yep. Yep, you haven't asked too many questions. Here's gloves for you. And
The glasses.
gloves for you. Alright, so maybe you could all pick a different stain that you want to test because you think it might be blood. So maybe if you pick a stain, this here on the rib, yep. So I'm going to give you one of these. It is quite hard to put on, isn't it? That's alright, we'll come circle around to you. So there you go, so if you want to put a wee drop, so if you tip it up like this, it's easier. And you just put a wee drop on like that, there you go. And now you just rub it onto some of the area. Alright, so we're just testing this. So you need to, it's quite hard to stretch it on, and then you turn it around. There's blood.
Oh my god.
Wait, it's
It's an
Here we go. Who else is having a go? Who's going to have a go once we've got your drop on? That's alright, don't rush. Alright. So what stain do you want to test? That one up there in the pocket? I'll do this. You want to do that little one? Okay, that's good for you. And if you just drop a little bit of water so it can hold. There you go. Squish it on. And then turn it around. Yes, that is blood.